Hi everyone, my name is Aria, and I work alongside Whitroy as an electrical tutor. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 3000, 2018. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for EWRB exam. What this audiobook does is take the key ideas from the standard and explain them in simple, spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real installations. So think of this as a learning companion, not a replacement for the actual standard. Alright, let's get started. Welcome to Section 7 of ASNZS 3000, Special Electrical Installations. In this section, we move away from standard electrical installations and focus on situations where extra care, additional controls, or special design rules are required. These include safety services, electricity generation systems, electrical separation, extra low voltage systems, high voltage installations, hazardous areas, and other specialized applications. Each part of this section explains how normal installation rules are adjusted or added to, so electrical safety is maintained even in high risk or unusual environments. Everything in this section builds on the core safety principles of the standard while addressing the specific needs of these special installations. Clause 7.1 General. This clause introduces Section 7 and explains that this part of ASNZS 3000 deals with special electrical installations. It sets the scene by making it clear that this section focuses on installations that have higher risks or special conditions compared with normal electrical work, and that these installations still need to meet the overall safety intent of Part 1 of the standard. Clause 7.1.1 Application. This clause explains that Section 7 sets out the minimum requirements for how electrical equipment is selected and installed when it is used in special electrical installations. The key idea is that these requirements must be met so that the installation still satisfies the general safety principles of Part 1 of ASNZS 3000, even though the installation itself is unusual or has added risks. Clause 7.1.2 Selection and Installation. This clause explains that each type of special electrical installation has its own specific requirements, and these requirements can replace or change the general rules found in other sections of the standard. It also makes clear that if Section 7 does not state a specific requirement for a situation, then the normal requirements from the other sections of ASNZS 3000 still apply. The clause then explains that this section applies to a range of special electrical installations, including electrical systems used for safety services, electricity generation systems, protection methods that use electrical separation, extra low voltage electrical installations, and high voltage electrical installations. It also applies to installations in areas where there may be an explosive hazard, and to electrical installations in particular locations or situations such as construction and demolition sites, electromedical treatment areas, transportable structures and vehicles and the places they are supplied from, marinas and recreational boats, shows and carnivals, cold cathode illumination systems, telecommunication networks, power supplies, cranes and hoists, lifts, generating sets, outdoor sites under heavy conditions, and electric fences. Clause 7.2 Safety Services. This clause introduces the part of ASNZS 3000 that deals specifically with safety services. It explains that these rules apply to electrical installations that must keep working so that people can be protected during emergencies, such as fires or other dangerous situations. Clause 7.2.1 Scope in General. This clause explains that Clause 7.2 sets the overall boundaries for safety services and how they are treated within an electrical installation, focusing on systems that are critical to safe operation when normal conditions are lost. Clause 7.2.1.1 Scope. This clause explains that the requirements of Clause 7.2 apply to building services that are essential for safety. These include systems needed for fire detection, warning and extinguishing, smoke control, evacuation systems, and any electrical systems that protect the safety of people who rely on lifts during emergencies. The key idea is that these systems must remain reliable so they can function when they are most needed. Clause 7.2.1.2 General. This clause explains that the main purpose of these requirements is to make sure the electricity supply to safety equipment is not accidentally disconnected. The intent is that equipment needed during emergency conditions must continue to receive power so it can operate properly when normal building services may be failing. The clause then explains that some equipment does not need to comply with Clause 7.2, including escalators or moving walkways, certain lifts in single private homes installed to the correct lift standard, lifts that are not classed as emergency lifts under building codes, some pumps where failure would not affect fire water supply, deleted text that no longer applies, and smoke alarms in single private homes which are covered elsewhere. The notes explain that other standards give guidance for emergency power in hospitals, clarify how the term safety services has been used in different editions and building codes, and explain that fire resistance level is expressed in minutes and relates to structural adequacy, integrity, and insulation as defined by the relevant building and fire standards. Clause 7.2.2 Supply Systems. This clause explains how power supplies for safety services must be arranged. It states that wiring systems for safety services must be able to keep supplying electricity to equipment even when exposed to fire. It also explains that a power source intended for safety services must not be used for other purposes if doing so would reduce the availability of power for safety services. Where safety services need to operate during emergencies or when the normal supply is lost, it may be necessary to automatically disconnect non-essential equipment so enough capacity is available for safety services. An exception is explained for certain fire detection, alarm and intercom systems that use compliant battery backup supplies. Clause 7.2.2.1 General. This clause reinforces that wiring systems associated with safety services must be selected and installed so that they can maintain supply under fire conditions, and that the integrity of the supply takes priority over normal electrical loads. Clause 7.2.2.2 WS classification is not provided. This clause explains what to do when a relevant standard does not specify a wiring system classification. It states that in these cases, the wiring system must either be able to keep supplying power when exposed to fire or mechanical damage, or be protected so that fire or mechanical damage will not prevent it from supplying the equipment. It explains that this can be achieved by suitable enclosures or by locating the wiring where it will not be exposed to damage. The clause also explains that conductors supplying safety services must be physically separated from other wiring systems by a minimum distance or by suitable barriers, and must also be separated from other safety services. It further explains that conductors for different safety services must not be combined together within the same multi-core cable, and must not be combined with conductors of other wiring systems. Where cabling passes through areas with different protection requirements, the highest level of protection must be applied unless it is not practical to do so. The clause then explains exceptions where fire protection requirements do not apply, such as wiring installed in locations that already provide protection, certain battery-backed emergency systems, and wiring for electric-driven fire pumps that are part of a larger pump arrangement. Clause 7.2.2.2 Wiring Systems. This clause explains that wiring systems supplying safety services, including their supports, must comply with the relevant wiring system standard and the required wiring system classification, depending on what equipment is being supplied and where it is installed. Clause 7.2.2.3 Alternative Supply Systems. This clause explains that alternative supplies may be needed so a building can continue to be used safely when the normal power supply is lost. It explains that the alternative supply must have enough capacity to operate all required safety services and, where needed, to support continued occupation of parts of the building. It also explains that generating sets or other independent power sources must be sized to supply all safety services at the same time, including allowance for motor starting. The clause notes that a separate alternative supply may also be provided for non-safety purposes such as security or protecting business assets. Clause 7.2.2.3.1 Continued occupation. This clause explains that where an alternative supply is provided to allow people to remain safely in a building, it must be capable of supplying both safety services and the electrical equipment needed for continued occupation during a loss of normal supply. Clause 7.2.2.3.2 Fire Management System. This clause explains that when a fire management system is used to control safety services, it must be connected to the alternative supply. The alternative supply must have enough capacity to operate all the required safety services in fire mode, including allowances for starting motors or staged operation of equipment. Clause 7.2.3 Main switchboard and switchgear. This clause explains that special arrangements are required for switchboards and switchgear supplying safety services so that faults in the general installation do not affect critical safety equipment. Clause 7.2.3.1 General. This clause explains that each safety service must be controlled by a main switch that is separate from the switches used for the rest of the installation and from switches used for other safety services. It also explains that main switchboards must be installed in accordance with the relevant installation and building code requirements. Clause 7.2.3.2 Switchgear. This clause explains that switchboards supplying safety services must be constructed so the safety services switchgear is separated from general switchgear by metal partitions. The purpose is to reduce the chance that a fault in the general installation will spread to the safety services. It also explains that non-metallic cases do not meet this requirement. Clause 7.2.3.3 Cables in the same enclosure. This clause explains that conductors for safety services must not be enclosed together with conductors for other safety services or other wiring systems. It then explains how separation can be achieved using divided ducts, compliant wiring systems, or physical separation within switchboards so that effective segregation is maintained. Clause 7.2.3.4 Arrangement. This clause explains that where a supply isolating device is installed, it must be capable of breaking load, such as a load break switch or circuit breaker. It also explains that discrimination must be achieved between protective devices if a circuit breaker is used. The clause notes that additional requirements may apply, including the ability to lock the device on and labeling to restrict operation to authorized personnel only. Clause 7.2.3.5 Discrimination selectivity of circuit protective devices. This clause explains that protective devices must be selected so that a fault on one safety service does not cause loss of supply to other safety services, and that a fault in the general electrical installation must not interrupt power to safety services. It also explains that fault current limiting devices used to protect safety services must not be used to protect general installation circuits. Finally, it explains that discrimination must be arranged between outgoing circuit protection and upstream protective devices so faults are cleared in the correct order. Clause 7.2.4 Main switches. This clause explains the requirements for main switches used to control safety services. The key idea is that safety services must have their own dedicated control so that they are not affected by faults or switching in the general electrical installation. Clause 7.2.4.1 General. This clause explains that every safety service must be controlled by a main switch that is separate from main switches used for any part of the general electrical installation and also separate from main switches used for other safety services. The purpose is to make sure that a fault on one safety service does not cause loss of supply to other safety services, and that a fault in the general electrical installation does not interrupt power to safety services. It explains that there is no limit on how many main switches may be installed to control safety services if needed. It also explains that an automatic transfer switch may be used as a main switch, provided it meets the requirements of Clause 2.3.3. The clause further explains that fault current limiting devices used to protect safety services must not be used to protect any part of the general electrical installation. Clause 7.2.4.2 Arrangement of main switches. This clause explains how main switches for safety services must be arranged. It states that they must be connected on the supply side of all general electrical installation main switches, must not be subject to the control of any general electrical installation main switch, and must control only electrical equipment that is regarded as safety services. The clause then explains that this requirement does not need to apply to certain situations, including high-voltage switches supplying low-voltage switchboards that are not regarded as general installation main switches, low-voltage switches that can only be operated by authorized persons and are clearly marked, safety services installed in individual or combined outbuildings or fire-separated portions of a building, and certain automatic fire detection, alarm, sound and intercom systems provided they meet the stated supply, marking and secondary power source requirements. Clause 7.2.4.3 Mechanical Protection. This clause explains that switches and control equipment forming part of a safety service installation must be adequately protected if their location or conditions of use mean they could be subject to mechanical damage. The intent is to make sure the switch remains operable during an emergency. Clause 7.2.4.4 Identification. This clause explains that all switches operating in the supply circuit to safety services must be clearly identified so it is obvious which safety service they control. It explains that main switches for safety services must be identified as a main switch, must clearly indicate the safety service equipment they control using uppercase lettering, must be marked with the words "in the event of fire do not switch off" in uppercase, and must also be identified by contrasting color or another suitable method so they can be quickly recognized. Clause 7.2.4.5 Electrical installations and outbuildings. This clause explains that where a switch for safety services is installed on a switchboard in an outbuilding, that switch is regarded as a main switch for the purposes of this clause. It also explains that a safety service main switch installed in an outbuilding must be clearly identified in accordance with Clause 7.2.4.4. The clause further explains that any switch located remote from an outbuilding, or operating in the supply circuit to a safety service main switch installed in the outbuilding, must also be clearly identified with the required markings. Clause 7.2.4.6 Fire-separated portions of a building. This clause explains that where switches controlling safety services are installed in a fire-separated portion of a building and provided on the switchboard within that fire-separated portion, they are regarded as main switches and must be arranged in accordance with Clause 7.2.4. It explains that parts of a structure separated by a fire resistance level of at least 120/120/120 minutes may be treated as a separate building for this purpose. The clause also explains that any switch controlling safety services in such a fire-separated portion must be separated from switches used to control the general electrical installation and other safety services. Clause 7.2.5 Fire pumps and fire pump control equipment. This clause introduces the requirements for electrical installations supplying fire pumps and their control equipment. The intent is to ensure that these systems remain reliable during emergency conditions. Clause 7.2.5.1 General. This clause explains that fire pumps and fire pump control equipment include items such as fire hydrant booster pumps, pumps for automatic sprinkler or spray or deluge systems, pumps for fire hose reels where they are the sole means of fire protection, fire pump control equipment and wiring systems, and fire pump rooms. It also explains that there may be other fire and smoke control equipment not listed. An exception is explained, stating that the requirements of Clause 7.2 do not apply to electrical equipment where failure would not affect the operation of safety services. Clause 7.2.5.2 Wiring system supplying fire pumps and fire pump control equipment. This clause explains that wiring systems supplying fire pumps and their control equipment must comply with ASNZS 3013 and have the required wiring system classification specified by the relevant installation standard. It explains that where no wiring system classification is specified, the wiring must be capable of maintaining supply when exposed to fire or mechanical damage, or be protected so that supply can be maintained. It also explains exceptions where these protection requirements do not apply, such as wiring installed in locations that already provide protection, or wiring for electric-driven fire pumps that are part of a pump set with a standby fuel-driven pump. Clause 7.2.5.2.2, Segregation of cables. This clause explains that conductors supplying fire pumps and fire pump control equipment must not be enclosed with conductors of different safety services or with conductors of any other wiring system. It explains how effective segregation can be achieved using separate channels, compliant wiring systems, physical separation within switchboards, and by ensuring that conductors of different safety services are not combined within the same multi-core cable. Clause 7.2.5.3, Switchgear for fire pumps and fire pump control equipment. This clause explains that where emergency equipment is required by building codes, switchboards supplying that equipment must be constructed so that the emergency equipment switchgear is separated from other switchgear by metal partitions. The intent is to reduce the risk of a fault spreading from general switchgear to emergency switchgear. Clause 7.2.5.4, Interposing switches for fire pumps and fire pump control equipment. This clause explains that no switch is permitted to be installed between a main switch and downstream switchboards that supply fire pumps and fire pump control equipment. The purpose is to avoid any unintended interruption of supply. Clause 7.2.5.5, Pump rooms for fire pumps and fire pump control equipment. This clause explains that in rooms used mainly to house fire pumps, lighting equipment and socket outlets may be supplied as a final subcircuit from the pump supply, provided that the circuit is protected against overcurrent, protected by an RCD not exceeding 30 mA, and that the wiring system between the pump circuit and the final subcircuit protective device meets the current carrying capacity, installation, type and segregation requirements of the relevant clauses. An exception is explained for lighting and socket outlets in pump rooms where certain wiring system requirements do not need to apply. Clause 7.2.5.6, Fire pump motors. This clause introduces the requirements that apply specifically to motors used to drive fire pumps. Clause 7.2.5.6.1, Isolating switches for fire pump motors. This clause explains that where fire pump motors are automatically controlled, a manually operated isolating switch must be installed on the supply side of the pump motor. It explains that this isolating switch must meet the requirements of the relevant clauses, be installed adjacent to the motor, and be provided with a device that allows the switch to be locked in the closed position. Clause 7.2.5.6.2, Overcurrent protection for fire pump motors. This clause explains that overcurrent protective devices for fire pump motors must have inverse time characteristics. It explains that circuit breakers must be rated to carry 125% of the full load motor current continuously, and must not open the circuit in less than 20 seconds at 600% of full load current. It also explains that no other overload protective device may be installed between the motor controller and the motor. Where more than one motor is supplied from the same circuit, the protection must be set to carry 125% of the combined full load current and meet the same minimum opening time requirement based on the largest motor. Clause 7.2.5.6.3, Overtemperature protection for fire pump motors. This clause explains that overtemperature protective devices must not be provided on fire pump motors where their operation could reduce the operating time of the equipment during emergency conditions. Clause 7.2.5.6.4, Control circuits for fire pump motors. This clause explains that control circuits for fire pump motors must be directly connected between the active and neutral conductors of the pump circuit, which means transformers are not permitted. It explains that the active conductor of the control circuit must be directly connected to the operating coil within the starter, and that no overload protective devices are allowed in the control circuit other than those provided for the pump motor circuit. It also explains that this arrangement requires a switch to be installed in the neutral conductor of the control circuit for the fire pump motor. Clause 7.2.6, Fire and smoke detection equipment and fire alarm systems. This clause introduces the requirements for electrical installations supplying fire and smoke detection and alarm systems. The intent is to ensure these systems remain reliable so they can detect fire, warn occupants, and support emergency response when required. Clause 7.2.6.1 General. This clause explains that fire and smoke detection and alarm systems include fire and smoke detection equipment, fire indicator panels, fire and smoke alarm systems, and warning and intercom systems. The key idea is that all of these elements together form the safety service responsible for detecting fire and alerting people. Clause 7.2.6.2 Wiring systems for fire detection and alarm systems. This clause introduces the requirements for wiring systems that supply fire detection and alarm systems, focusing on maintaining supply and system integrity under emergency conditions. Clause 7.2.6.2.1 Types of wiring systems for fire detection and alarm systems. This clause explains that wiring systems supplying fire detection and alarm systems must comply with ASNZS 3013 and use a wiring system classification specified by the relevant installation standard. Where no wiring system classification is specified, the wiring must be capable of maintaining supply when exposed to fire or mechanical damage, or must maintain supply when exposed to fire while also being protected against mechanical damage. This protection may be achieved by installing the wiring in an effective enclosure or locating it where mechanical damage will not occur. The clause then explains that these fire and mechanical protection requirements do not apply where the wiring is already installed in a location or enclosure that provides protection, or where circuits provide the primary power source to fire detection and alarm systems that have compliant battery backup up to the control and indicating panel, or for circuits supplying emergency warning systems beyond the main equipment panel when they comply with the relevant standards. Clause 7.2.6.2.2 Segregation of cables for fire detection and alarm systems. This clause explains that conductors for fire detection and alarm systems must not be enclosed with conductors of different safety services or with conductors of any other wiring system. It explains that effective segregation may be achieved by dividing ducts or trunking into separate channels with continuous barriers, by physically separating wiring systems from all others by at least 50 mm or using effective barriers, and by ensuring conductors of different fire and smoke detection and alarm systems are not combined together or mixed with other wiring systems within the same multi-core cable. Clause 7.2.6.3 Interposing switches for fire detection and alarm systems. This clause explains that no switch is permitted to be installed between a main switch and downstream switchboard supplying fire and smoke detection and fire alarm systems, so that supply cannot be accidentally interrupted. Clause 7.2.7 Air handling systems. This clause introduces air handling systems that are intended to exhaust and control the spread of fire and smoke, and confirms that these systems are treated as safety services. Clause 7.2.7.1 General. This clause explains that air handling systems used to control fire and smoke movement are safety services and must therefore meet the requirements that ensure reliable operation during emergencies. Clause 7.2.7.2 Wiring systems for air handling systems. This clause introduces the wiring requirements for air handling systems used for fire and smoke control. Clause 7.2.7.2.1 Types of wiring system for air handling systems. This clause explains that wiring systems supplying air handling systems must comply with ASNZS 3013 and use the wiring system classification specified by the relevant installation standard. Where no wiring system classification is specified, the wiring must be capable of maintaining supply when exposed to fire or mechanical damage, or must maintain supply when exposed to fire while being protected against mechanical damage, either through an effective enclosure or by location. It also explains that these protection requirements do not apply where the wiring is already installed in an enclosure or location that provides adequate fire and mechanical protection. Clause 7.2.7.2.2 Segregation of cables for air handling systems. This clause explains that conductors supplying air handling systems must not be enclosed with conductors of different safety services or with conductors of any other wiring system. It explains that segregation may be achieved using divided ducts or trunking with continuous barriers, physical separation of at least 50 mm or effective barriers, and by ensuring conductors of different safety services are not combined within the same multi-core cable. Clause 7.2.7.3, interposing switches for air handling systems. This clause explains that no switch is permitted to be installed between a main switch and downstream switchboard supplying air handling systems, to prevent unintended loss of supply. Clause 7.2.8, evacuation equipment. This clause introduces evacuation equipment used during emergencies to assist people to leave a building safely. Clause 7.2.8.1, general. This clause explains that evacuation equipment includes sound systems and intercom systems used for emergency purposes that comply with AS 1670.4. It also notes that emergency evacuation lighting requirements are addressed by building codes. Clause 7.2.8.2, wiring systems for evacuation equipment. This clause introduces wiring system requirements for evacuation equipment. Clause 7.2.8.2.1, types of wiring system for evacuation equipment. This clause explains that wiring systems supplying evacuation equipment must comply with ASNZS 3013 and use a wiring system classification specified by AS 1670.4. Clause 7.2.8.2.2, segregation of cables for evacuation equipment. This clause explains that conductors supplying evacuation equipment must not be enclosed with conductors of different safety services or with conductors of any other wiring system. It explains that effective segregation can be achieved using divided ducts or trunking, physical separation of at least 50 mm or effective barriers, and by ensuring conductors of different safety services are not combined within the same multi-core cable. Clause 7.2.8.3, interposing switches for evacuation equipment. This clause explains that no switch is permitted to be installed between a main switch and downstream switchboard supplying evacuation equipment. Clause 7.2.9, emergency lifts. This clause introduces requirements for lifts that are required to operate for firefighting or other emergency purposes and are treated as safety services in New Zealand. Clause 7.2.9.1, general. This clause explains that in New Zealand, lifts required to operate for firefighting or other emergency purposes are safety services and must comply with the requirements of this section. Clause 7.2.9.2, control and protection. This clause explains that each emergency lift, or group of emergency lifts, must be controlled and protected independently of all other lifts. It explains that main switches controlling lifts must be arranged in accordance with Clause 7.2.4 and clearly identified so they are distinguishable from switches controlling other lifts. Clause 7.2.9.3, wiring systems for emergency lifts. This clause introduces wiring requirements for emergency lifts. Clause 7.2.9.3.1, types of wiring system for emergency lifts. This clause explains that wiring systems supplying emergency lifts must comply with ASNZS 3013 and use the wiring system classification specified by the relevant installation standard. Where no wiring system classification is specified, the wiring must be capable of maintaining supply when exposed to fire or mechanical damage, or must maintain supply when exposed to fire while being protected against mechanical damage, either by effective enclosure or by suitable location. It also explains that these protection requirements do not apply where wiring is already installed in a protected enclosure or location, or for circuits supplying lifts beyond the terminals of a circuit breaker in the lift machine room used for control and protection of the lift installation. Clause 7.2.9.3.2, segregation of cables. This clause explains that conductors supplying lifts must not be enclosed with conductors of different safety services or with conductors of any other wiring system. Clause 7.2.9.4, interposing switches. This clause explains that no switch is permitted to be installed between a main switch for lifts and downstream lift switchboards, except where an alternative supply system is provided or where switches are located remote from the building being supplied. Clause 7.2.9.5, switchgear. This clause explains that where emergency equipment is required by building codes, switchboards supplying that equipment must be constructed so that emergency switchgear is separated from other switchgear by metal partitions to limit the spread of faults. Clause 7.2.10 Emergency motor room less lifts. This clause introduces additional requirements for emergency motor room less lifts, also known as MRL lifts. Clause 7.2.10.1 General. This clause explains that motor room less lifts do not require a traditional lift motor room due to their design. It explains that an MRL switchboard must comply with Clause 2.10, and that MRL lifts fitted for emergency evacuation, firefighting activities, or designated as emergency lifts must meet the additional requirements of this clause. Clause 7.2.10.2 Switchboards. This clause explains that an MRL switchboard must not be located in the lift shaft. It also explains that switchboards located remote from the main switchboard and dedicated to supplying individual MRL switchboards must be readily accessible and enclosed in a fire-rated room or enclosure. Clause 7.2.10.3 Switchgear. This clause explains that an MRL switchboard must be located in a readily accessible position, and that where the switchboard penetrates into the lift shaft, the fire rating must be maintained in accordance with the relevant clause. Clause 7.2.10.4 Wiring systems. This clause introduces wiring system requirements for MRL lifts. Clause 7.2.10.4.1 Types of wiring systems for MRL lifts. This clause explains that wiring systems supplying MRL lifts must comply with ASNZS 3013 and use the wiring system classification specified by the relevant installation standard. Where no wiring system classification is specified, the wiring must be capable of maintaining supply when exposed to fire or mechanical damage, or must maintain supply when exposed to fire while being protected against mechanical damage, either through effective enclosure or suitable location. It also explains that these protection requirements do not apply where wiring is installed in a protected enclosure or location. Clause 7.2.10.4.2 Segregation of cables. This clause explains that conductors supplying MRL lifts must not be enclosed with conductors of different safety services or with conductors of any other wiring system, and that effective segregation may be achieved using divided enclosures, compliant wiring systems, or by ensuring conductors of different safety services are not combined within the same multi-core cable. Clause 7.3 Electricity generation systems. This clause introduces the requirements for electricity generation systems that are connected to electrical installations. It explains that these requirements add to or modify the rules in sections 2 to 7 of ASNZS 3000 when a generation system is used to supply all or part of an installation, whether it operates continuously or only at certain times, including systems that operate alongside other supplies. Clause 7.3.1 General. This clause explains that electricity generation systems may take several forms. It explains that an alternative or supplementary supply may be provided by a generator set, typically driven by a combustion engine, which may supply an alternative or standby alternating current supply when the normal supply fails, may act as the primary power supply to an installation, or may be used as part of a standalone power system. It also explains that a standalone power system is not connected to a network provider's distribution system and may be supplied from sources such as photovoltaic arrays, wind turbines or mini hydro turbines, or engine-driven generator sets that provide either alternating current or direct current. The clause then explains that an inverter system may supply alternating current using an interactive inverter powered by renewable energy sources such as photovoltaic, wind or mini hydro systems. Where renewable energy output exceeds the installation load, any approved surplus energy may be exported into the distribution system, and where renewable output is insufficient, energy is imported from the network. It also explains that the interactive inverter controls both exporting and importing of energy. The clause further explains that a battery system may be used to store energy from sources such as generators, photovoltaic arrays, wind turbines or mini hydro turbines in order to supply alternating current to an electrical installation. Clause 7.3.2 Selection and installation of system. This clause explains that the selection, installation and control of electrical equipment forming part of an electricity generation system must comply with the relevant standards for the type of system being installed. It explains that engine-driven generating sets, standalone power systems, battery systems, photovoltaic array systems and inverter systems each have specific standards that must be followed so that the system operates safely and correctly. Clause 7.3.3 Control. This clause explains that an electricity generation system must be controlled by a main switch or switches located at the installation switchboard where the system connects to the installation. It explains that suitable switches or devices must be provided for starting and stopping the generation system, and where more than one control device is used they must be grouped together and clearly identified. It also explains that the system must be arranged so it cannot supply energy upstream of the point of connection to the installation, either directly or indirectly, unless a formal agreement exists with the electricity distributor. The clause notes that conditions for grid-connected and cogeneration systems operating in parallel with the network are outside the scope of this standard. Clause 7.3.3.1 Basic protection and fault protection. This clause explains that all necessary connections for basic and fault protection, including the MEN connection, must remain intact when supply is available from the electricity generation system. The intent is to ensure that protective measures continue to operate correctly regardless of whether power is coming from the network or the generator. Clause 7.3.4 Isolation. This clause introduces the isolation requirements for electricity generation systems so that equipment can be safely disconnected when required. Clause 7.3.4.1 General. This clause explains that an inverter or regenerative supply source must not be connected downstream of a generating set changeover device, unless control systems prevent backfeed to the generator. It explains that every electricity generation system must be provided with an isolating switch in accordance with the relevant clause. The isolating switch must be installed adjacent to or on the generation system so the operator has a clear view of anyone working on the system, or it must have a means of securing it in the isolated position that requires a deliberate action to operate. It explains that the isolating switch may be combined with overcurrent protection where permitted, must comply with the relevant motor isolation requirements where an electric motor is involved, must be under manual control only, and must not be capable of being overridden or bypassed by programmable control systems. It also explains that isolation location requirements may be varied by other related standards. Clause 7.3.4.2 Electricity generation systems incorporating batteries. This clause explains that where batteries are included in an electricity generation system, a switch capable of interrupting the battery supply must be installed adjacent to the batteries and must be clearly identified to indicate its purpose. It also explains that a single switch incorporating both alternating current and direct current switching functions may be used where permitted. Clause 7.3.5 Overcurrent protection. This clause introduces the requirements for overcurrent protection in electricity generation systems. Clause 7.3.5.1 Electricity generation system protection. This clause explains that electricity generation systems must be provided with overcurrent protection in accordance with the applicable standards for the particular system. Where no specific requirement is given, it explains that overcurrent protective devices must be located as close as practicable to the output terminals of the generation system so that unprotected interconnecting conductors are as short as possible and never exceed 15 meters. It also explains that unprotected interconnecting conductors must be completely enclosed by non-combustible material or installed underground. The clause explains that overcurrent protection may be provided by protective devices within the generation system itself, or by the characteristics of the system that limit fault current. It further explains that where systems operate in parallel, circulating harmonic currents must be limited so conductor current carrying capacity is not exceeded, and it outlines practical methods for achieving this. Clause 7.3.5.2 Circuit protection. This clause introduces requirements for protecting individual circuits supplied from electricity generation systems. Clause 7.3.5.2.1 General. This clause explains that prospective short-circuit current and prospective earth fault current must be assessed for each electricity generation system or combination of systems supplying an installation. It explains that the short-circuit rating of protective devices must not be exceeded under any intended operating condition. It also explains that where electronic overcurrent protection is fitted within a generation system, such as in inverters, the system may automatically limit output current and may prevent the operation of external protective devices during fault conditions. The clause explains that every outgoing circuit must be individually protected and include additional earth leakage protection where required. It also explains when a circuit may be considered protected against prospective short-circuit earth fault currents due to the limited output capability of the generation system. Clause 7.3.5.2.2 RCDs. This clause explains that the waveform of fault current to earth from electricity generation systems can affect the operation of RCDs and must be considered when selecting the RCD type. Where an inverter is used, the RCD must be suitable for the earth fault waveform produced by that inverter and must be installed in accordance with the manufacturer's instructions. Clause 7.3.6 Earthing. This clause explains that protective earthing in the electrical installation must use an MEN system in accordance with Section 5. It explains that any exposed conductive parts of the electricity generation system must be earthed by connection to the main earthing conductor at the main switchboard. Clause 7.3.7 Connected electrical equipment. This clause explains that any accessory, conductor, insulation or other component connected to the output side of an electricity generation system must be suitable for the voltage, current and frequency produced by the system. Clause 7.3.8 Connection to electrical installation. This clause introduces requirements for how electricity generation systems are connected to electrical installations. Clause 7.3.8.1 Alternative supplies. This clause introduces requirements for alternative or standby supplies connected to installations. Clause 7.3.8.1.1 General. This clause explains that the incoming neutral to AMEN switchboard must not be switched when connecting an alternative supply. It explains that the neutral earth connection must be made within the installation at the main switchboard, and this may require disconnection of any neutral earth link within a generation system such as an engine-driven generator. It explains that this applies to any switchboard fitted with a MEN connection, including switchboards in outbuildings regarded as main switchboards for earthing purposes. It also explains that neutral and earth conductors must not operate in parallel, and sets out the New Zealand-specific requirement that where a generating set is connected to a switchboard without a neutral earth link and the installation operates from the alternative supply, a neutral earth connection and connection to the mass of earth must be made in the distribution switchboard in accordance with ASNZS 3010. Clause 7.3.8.1.2 Switching. This clause explains that the changeover device for an alternative supply must be selected to maintain the function of, and prevent damage to, the electrical installation. It explains that this includes maintaining continuity of the neutral conductor, correct operation of RCDs, and continued uninterrupted power supplies. It explains that the changeover device must open all active conductors of the normal supply when the alternative supply is connected, and that automatic switching must be clearly marked. It also explains that switching arrangements complying with ASNZS 3010 are acceptable. Clause 7.3.8.2 Grid-connected inverter systems. This clause introduces requirements for inverter systems connected to the electricity network. Clause 7.3.8.2.1 General. This clause explains that connection of a grid-connected system is subject to formal agreement with the electricity distributor. Clause 7.3.8.2.2 Switching. This clause explains that a main switch must be provided to allow isolation of the inverter output from the switchboard to which it is connected, and that all switches must be clearly identified according to their function. Clause 7.3.8.2.3 Connection. This clause explains that grid-connected inverter systems must be connected in accordance with the ASNZS 4777 series and the requirements of the electricity distributor. It explains that the generation system must not impose a voltage on the installation outside permitted limits at the point of supply. Clause 7.3.8.3 Standalone power systems. This clause introduces requirements for standalone systems that are not connected to the electricity network. Clause 7.3.8.3.1 General. This clause explains that the consumer mains of the electrical installation must be connected to the output of the electricity generating system. Clause 7.3.8.3.2 Switching. This clause explains that control of the electrical installation supplied by a standalone system must be arranged in accordance with Clause 2.3. Clause 7.3.8.3.3 Connection. This clause explains that the method of connection for a standalone system must comply with the ASNZS 4509 series, and that typical arrangements include a local MEN connection at the switchboard. Clause 7.4 Protection by electrical separation isolated supply. This clause explains protection by electrical separation, which has the same meaning as isolated supply. The idea is to reduce the risk of electric shock by separating the supply so that dangerous touch voltages cannot occur under fault conditions. Clause 7.4.1 General. This clause explains that Clause 7.4 provides protection against electric shock from indirect contact and is recognized as complying with Clause 1.5.5. It explains that electrical separation is an alternative protection method and is intended, within an individual circuit, to prevent shock current flowing through exposed conductive parts that could become energized by a fault. It explains that protection by electrical separation is achieved by complying with clauses 7.4.2 to 7.4.4, together with clause 7.4.5 where a single item of equipment is supplied, or clause 7.4.6 where more than one item of equipment is supplied. Clause 7.4.2 Source of supply. This clause explains that a separated circuit must be supplied from a suitable source. The source may be an isolating transformer complying with ASNZS 61558 so that the output is separated from the input by double insulation or an equivalent method. It explains that higher transformer ratings are permitted where the relevant construction and verification provisions are applied. It also explains that a generator output may be used where the output is separated from the generator frame, or an isolated inverter complying with ASNZS 4763 may be used. The clause explains that fitting in RCD or additional bonding conductors to the generator output does not provide the required output separation. It also explains that the rated output of separated transformers or generators should be limited to suitable values to ensure safe operation. Clause 7.4.3 Arrangement of circuits. This clause explains that separated circuits must meet specific arrangement requirements. It explains that circuit voltage must not exceed 500 volts, and that all live parts of a separated circuit must be effectively separated from all other circuits and from earth. It explains that this requirement also applies to live parts of relays, contactors and similar equipment within the separated circuit. It further explains that exposed conductive parts supplied by a separated circuit must not be connected to protective earthing conductors, exposed conductive parts of other circuits, or the exposed conductive parts of the source of supply. It explains that cables and flexible cords must be protected against mechanical damage or arranged so any damage is readily visible. Clause 7.4.4 Switching devices. This clause explains that switching devices must operate in all live conductors of a separated circuit. It explains that switching the active conductor on the primary of an isolating transformer, in accordance with the relevant clause, is an acceptable method of control and disconnection. Clause 7.4.5 Supply to single item of electrical equipment. This clause explains that where a separated circuit supplies a single item of electrical equipment, any exposed conductive parts of that equipment must not be connected to exposed conductive parts of any other circuit, including other separated circuits, or to earth. Clause 7.4.6, supply to multiple items of electrical equipment. This clause explains that where a separated circuit supplies more than one item of electrical equipment, all exposed conductive parts of the separated circuit must be connected together by an insulated equipotential bonding conductor that is not connected to earth, protective earthing conductors, exposed conductive parts of other circuits, or extraneous conductive parts. It explains that socket outlet earth contacts must be connected to this equipotential bonding conductor, and that any designated protective earthing conductor and supply cables or flexible cords to equipment, other than Class II equipment, must also be connected to the equipotential bonding conductor. It explains that exposed conductive parts of the source of supply that are earthed must not be simultaneously accessible with exposed conductive parts of the separated circuit. It also explains that a protective device must disconnect the separated circuit automatically if two faults result in exposed conductive parts becoming connected to live parts of different polarity. Clause 7.4.7, Variable Speed Drive VSD-EMI filters. This clause explains that where a variable speed drive uses an EMI filter, the filter must not reference the frame of the system. It explains that only one EMI filter should be used on an isolated supply where multiple drives are used, and that filters referencing the frame can create harmful capacitive coupled currents. Clause 7.4.8, Testing. This clause introduces the testing requirements for separated circuits. Clause 7.4.8.1, General. This clause explains that in addition to Section 8 testing, the separation of each separated circuit must be individually confirmed. It explains that separation is verified by measuring insulation resistance between the separated circuit and the transformer primary winding where applicable, other wiring, other separated circuits, and earth. It explains that insulation resistance must not be less than 1 megohm when tested at 500 volts direct current. Clause 7.4.8.2, Single items of electrical equipment. This clause explains that where a single item of equipment is supplied from a separated circuit, separation must be verified by testing in accordance with the general testing clause and by measuring insulation resistance between earth and the exposed conductive parts, or the earth contact of a socket outlet. Clause 7.4.8.3, Multiple items of electrical equipment. This clause explains that where more than one item of equipment is supplied from a separated circuit, separation must be verified by testing in accordance with the general testing clause and by measuring insulation resistance between the separated circuit and the equipotential bonding conductor, between the equipotential bonding conductor and earth, and between the equipotential bonding conductor and any equipotential bonding conductor associated with another separated circuit. Clause 7.4.8.4, Bonding conductor continuity. This clause explains that the resistance of an equipotential bonding conductor for socket outlet earth contacts or exposed conductive parts connected to the same separated circuit must not exceed 0.5 ohms. Clause 7.5, Extra low voltage electrical installations. This clause introduces extra low voltage electrical installations and explains that they are considered to comply with basic and fault protection requirements by the use of extra low voltage. Clause 7.5.1, Scope. This clause explains that Clause 7.5 applies to installations operating at extra low voltage and that compliance with this clause is taken as compliance with basic and fault protection requirements. Clause 7.5.2, Application. This clause explains that extra low voltage installations must be either SELV or PELV systems. It explains that the requirements of this clause supplement or replace other section requirements, and that where an installation operates at extra low voltage but does not meet SELV or PELV requirements, it is treated as low voltage and must comply with other relevant sections. Clause 7.5.3, Sources of supply to SELV and PELV systems. This clause explains that SELV and PELV systems must be supplied from approved sources. These include a safety isolating transformer complying with ASNZS 61558, an independent source such as an engine-driven generator or battery, a separated source such as a motor generator set with electrically separate windings, or certain electronic devices designed so that output voltage cannot exceed extra low voltage under fault conditions. Clause 7.5.4 Separation requirements for SELV and PELV circuits. This clause explains that live parts of SELV and PELV circuits must be electrically separated from each other and from higher voltage circuits. It explains that separation must be equivalent to that provided by a safety isolating transformer, and that conductors must be segregated from other circuits. It also explains that live parts must be arranged so that short-circuiting or arcing will not occur under normal service conditions. Clause 7.5.5 Arrangement of SELV circuits. This clause explains that live parts of SELV circuits must not be connected to earth, protective earthing conductors, exposed conductive parts of other systems, or extraneous conductive parts. It explains limited exceptions where connection to extraneous conductive parts is inherently required and voltage cannot exceed SELV limits. It also explains that where SELV circuits may come into contact with other exposed conductive parts, protection against electric shock may depend on the protection applied to those other parts. It explains that where nominal voltage exceeds specified values, basic protection must be provided by barriers, enclosures, or insulation capable of withstanding specified test voltages. Clause 7.5.6 Arrangement of PELV circuits. This clause explains that for PELV circuits where one output conductor is earth, basic protection must be provided by barriers or enclosures of suitable IP rating, or by insulation capable of withstanding specified test voltages. It explains exceptions where basic protection may be unnecessary under defined low voltage and dry conditions, and notes requirements relating to earthing and insulation performance. Clause 7.5.7 Voltage drop in conductors. This clause explains that voltage drop in extra low voltage installations must not exceed 10% of nominal voltage when conductors are carrying operating current. It explains that information on voltage drop is provided in ASNZS 3008.1, and that this requirement does not apply where equipment is designed to operate with a higher voltage drop, such as during motor starting or similar transient conditions. Clause 7.5.8 Control of an electrical installation. This clause explains that an extra low voltage electrical installation must be controlled by one or more main switches that operate in all unearthed conductors. The purpose is to ensure the supply can be safely disconnected when required. It also explains that this requirement does not apply where the extra low voltage installation is supplied from part of a higher voltage installation and switching the higher voltage main switch disconnects the supply to the extra low voltage system. Clause 7.5.8.1 Main switches. This clause clarifies that the control of supply to an extra low voltage installation must be achieved using main switches that operate in all unearthed conductors, ensuring complete disconnection of the supply when operated. Clause 7.5.8.2 Other switches. This clause explains that switches used within an extra low voltage installation must be suitable for the system arrangement. Where the extra low voltage supply is earthed at the point of supply, such as PELV, the switch must operate in all unearthed conductors. Where the system is SELV, switches may operate in one fewer conductor than the total number of conductors in the circuit. Clause 7.5.9 Overcurrent protection. This clause introduces the requirement for protection against overload and short-circuit currents in extra-low voltage circuits to prevent damage in unsafe conditions. Clause 7.5.9.1 General. This clause explains that every extra-low voltage circuit must be individually protected at its origin against overload and short-circuit currents using a suitable protective device. The protection must comply with the general requirements for protection against overcurrent. It also explains that where the extra-low voltage supply is earthed at the point of supply, protective devices must be installed in all unearthed conductors. Certain circuits arranged under specific conditions may not require overcurrent protection. Clause 7.5.9.2 Emission of overcurrent protection. This clause explains that overcurrent protection may be emitted where interrupting the supply would create a greater danger than the overcurrent itself, or where the rated output of the source does not exceed the rating of the circuit. It describes acceptable sources, including short-circuit-proof transformers with limited output current, or batteries with high internal resistance such as primary cells. Clause 7.5.10 Connecting devices. This clause explains that plugs and socket outlet devices used for SELV and PELV systems must be designed so they cannot be interchanged with devices of other voltage systems. It also explains that socket outlets must not accept plugs from other voltage systems and must not include a contact for a protective earthing conductor. Clause 7.5.11 Wiring systems. This clause introduces requirements for wiring systems used in extra-low voltage installations, focusing on suitability and protection based on installation conditions. Clause 7.5.11.1 General. This clause explains that conductors and cable insulation for extra-low voltage installations must be suitable for their intended purpose and normally do not require additional protection unless installation conditions demand it. Attention is drawn to segregation requirements where extra protection may be needed in certain situations. Clause 7.5.11.2 Aerial conductors. This clause explains that aerial conductors used in extra-low voltage installations must be installed in accordance with the relevant requirements for overhead wiring. It also explains that certain clearance requirements may not apply if alternative protective measures are satisfied, and that bare conductors may be used where permitted for insulated conductors. Clause 7.5.11.3 Underground conductors. This clause explains that there are no specific burial depth requirements for extra-low voltage cables from a safety perspective, but careful consideration must be given to the risk of mechanical damage. Clause 7.5.12 Testing. This clause introduces the testing requirements that confirm the separation and safety of extra-low voltage circuits. Clause 7.5.12.1 General. This clause explains that the separation of extra-low voltage circuits must be verified by insulation resistance testing. It clarifies that different verification methods apply depending on whether protection is achieved by SELV or PELV. Clause 7.5.12.2 Protection by SELV. This clause explains that, for SELV systems, separation of live parts from other circuits and from earth must be confirmed by measuring insulation resistance. Clause 7.5.12.3 Protection by PELV. This clause explains that, for PELV systems, separation of live parts from other circuits must also be confirmed by insulation resistance measurement. Clause 7.9 Supplies for electric vehicles. This clause introduces additional requirements that apply to electrical installations intended for charging electric vehicles in New Zealand. Clause 7.9.1 Scope. This clause explains that the requirements apply to parts of electrical installations used for charging electric vehicles in New Zealand. It also highlights that electric vehicle charging can affect maximum demand and may require notification to the electricity distributor. Clause 7.9.2 Supply. This clause introduces requirements for how the supply to electric vehicle charging installations must be arranged. Clause 7.9.2.1 Source of supply. This clause explains that the supply for electric vehicle charging must not be taken from a switchboard located in an outbuilding that has a separate MEN earthing system. Clause 7.9.3 Domestic electrical installations. This clause introduces specific requirements for domestic installations in New Zealand that provide facilities for charging electric vehicles. Clause 7.9.3.1 Facilities for other than Mode 1 charging. This clause explains that new domestic electrical installations with an enclosed garage or similar space intended to accommodate a motor vehicle must include a facility to enable electric vehicle charging, using approved charging modes. Clause 7.9.3.2 Facilities for Mode 2 charging. This clause explains that Mode 2 charging facilities must meet requirements for minimum circuit capacity, dedicated final subcircuits, compliant socket outlets, minimum installation height, and appropriate switching and protection. Clause 7.9.3.3, Facilities for Mode 3 and Mode 4 charging. This clause explains that higher mode charging systems must comply with requirements for circuit capacity, dedicated final subcircuits, suitable CD protection, direct connection of equipment, provision of an isolating switch, and minimum installation heights for outlets or cables. Clause 7.9.4, Other electrical installations. This clause explains that electrical installations associated with electric vehicle charging, other than those specifically covered, must be protected by a separate CD of the appropriate type and rating, ensuring protection of all live conductors and safe operation of the charging system. That brings us to the end of Section 7, Special Electrical Installations. You should now have a clear understanding of how electrical safety is managed when installations fall outside normal conditions, and why extra requirements are applied in these situations. Always remember that these special rules work alongside the general requirements of ASNZS 3000, not instead of them. Correct design, selection, installation, control, protection, and verification are essential to keep people, property, and equipment safe. For any installation that falls into these categories, always refer back to the relevant clauses and supporting standards before carrying out work.